Hey friends, we are ready to rock and roll daily lesson 40, and we are going to look today at more applications of z-scores and percentiles within given specific word problem situations. So let's not waste any time with the small talk. Let's get right to business. First example, we are going to see here that over a 7-year period, the weight of babies born in a metropolitan hospital was normally distributed, meaning it had values, measurements that followed that bell-shaped curve. And the mean, the average weight was 6.8 pounds and a standard deviation of 0.8 pounds. So I'm going to use my knowledge of z-scores, how to find the z-score, and apply that then with my standard normal table as we used in daily 39 to help me find, in this case, in example 1, what percent of babies weighed less than 6.4 pounds. So first thing I'm going to do is find the z-score. Remember, the z-score is equal to your observation, 6.4, minus the mean, which we were told is 6.8, divided by standard deviation of 0.8. So when I simplify here, I'm going to have negative 0.4 over 0.8. So that's going to give me a z-score of negative 0.5. So for the percentile then, I'm going to figure out the percentile of babies here that would weigh less than 6.4 pounds. And remember, percentile tells us the value below. So we are good here. We want to find the z-score that negative 0.5 will correspond with in terms of a percentage. So I'm going to go to the negative side. 0.50 would be 0.3085. So that would indicate 30.85% of all babies born at this hospital would be less than 6.4 pounds. What happens, like in example 2, when you want to find the percent of babies that weighed more than 7.2 pounds? One extra step here. So my first step to find the z-score, I'm going to take the observation, 7.2 minus the mean, 6.8, divided by the standard deviation of 0.8. Well, 7.2 minus 6.8 is 0.4 divided by 0.8. That would be positive 0.5. So my z-score of positive 0.5 would be 0.6915. So 69.15%, remember, of babies would weigh below 7.2 pounds. But I'm asked here what percent weighed more or above 7.2. So in this case, I'm going to have to go 100 minus 69.15 and get 30.85. Good stuff. So that's the key there. To find the percent that is more than a given value, I'm going to have to take 100 minus the percent below. Here's one that's kind of just busy work. I want to find the percent that weighed between 6 and 7 pounds. So I need to find both values here, 6 and 7 z-scores. So observation 6 minus mean 6.8 divided by standard deviation of 0.8. That would be negative 0.8 divided by positive 0.8, which would be negative 1. And a z-score of negative 1 would correspond to a percentage of 15.87. A z-score of 7, so 7 minus 6.8 divided by 0.8 is going to give me 0.2 over 0.8, which is like a quarter, 0.25. So 0.25, I'm going to go to the positive, 0.2, and then 5 would be 59.87. And then to find the percent between these two, I'm just going to take the largest, 59.87, minus the smallest, 15.87. And that should come out to 44%. Last part here, working backwards, as we saw in the last 4 examples from the notes in Daily 39. Maybe you have these written down. That would be awesome. But we want to know, what would a baby need to weigh to, statistically be in the top 10%, meaning they would need a 90th percentile, 0.9000. So the closest z-score was that 0.8997, and again, that was a 1.28. So I'm going to say 1.28 equals observation minus mean of 6.8 divided by standard deviation of 0.8. So I'm going to work backwards here using inverse operations. I am going to first multiply both sides by, saved by the bell, 0.8. So we got 1.28 times 0.8. That is going to be 1.024. Will equal x minus 6.8. I can then add 6.8 to both sides. And get a weight of 7.824 pounds. Any baby weighing 7.824 pounds or more would be within that top 10%. Those will be the types of questions you will see today. We'll take a look at one more example to make sure we've got it down. We have test scores here that are normally distributed. The mean x bar is 75, and standard deviation sigma is 8. We want to know what percent of scores are below 87. So we'll find that z-score, observation minus mean over standard deviation. So 87 minus 75 is 12. 12 divided by 8, 1.5. So I'll go to my standard normal table, positive 1.5, and get 0.9332. So 93.32% of all scores would be below a 87. Now, again, when we want to find above, we'll find that percent and then go 100 minus. So above 71, I'll go observation minus mean divided by standard deviation. So 71 minus 75 is negative 4 over 8 will be negative 0.5. So negative 0.50 is the we found up here, just so you're aware, is that 30.85%. And then finding the percent above, I'll take 100 minus the percent below. 100 minus 30.85% will leave me with 69.15% above. All right, the brutal one, between 67 and 79. All right, observation minus mean of 75 divided by standard deviation of 8. Up above, we'll have the negative 8 over 8, which is negative 1, and a negative 1 z-score is a 15.87%. 79 minus 75 over 8 gives us 4 over 8, which is 0.5. 0.5 is, again, 69.15%. And subtracting here, my largest minus smallest, 69.15 minus 15.87. 69.15 minus 15.87. We've got 53.28% of all scores would be between 67 and 79, so a little more than half. And then finally, to be in the top 20%, you'd need to be at the 80th percentile or above, and our closest value is 0.84. That's 0.7997. So I'd need a z-score of 0.84. That would help me find the observation minus the mean of 75 divided by a standard deviation of 8. So again, I'll work backwards using those inverse operations, multiplying both sides by 8. 8 times 0.84 gives me 6.72, would equal x minus 75. Adding 75 to both sides, I'd end up with 81.72. Would need to be your score on the exam to finish in the top 20%. Have fun crunching and munching, getting your z-scores and going back and forth with your standard normal table.